Dear students, this is Kavita BS. In this session, we will have a discussion on Maxwell's law of velocity distribution. This topic is related to BSc course Physics subject paper 3rd, Thermal Physics, Radiation and Optics 1. This topic is in the chapter 1 of unit 1. Let us start the session. Maxwell's law of velocity distribution explains the distribution of velocities of the gas molecules. As we know that gas molecules are in random motion and continuously colliding with each other and also with the walls of the container. Due to this random motion and the magnitude and direction of the velocities of the gas molecules continuously changing. Therefore, Maxwell used statistical method in order to explain the velocity distribution of gas molecules. This is the only method which is applied to the system consisting of large number of elements. So, Maxwell, by using statistical method, he derived an expression for the velocity distribution. And that equation is dn is equal to 4 pi n a cube e to the power minus b c square into dc. This equation is derived by the Maxwell in order to explain the velocity distribution of gas molecules. Here, the dn term represents the number of molecules whose velocities lies between c and c plus dc. And in this equation, a and b are the constant terms. B is equal to m divided by 2 kT and a is equal to root of b by pi. And the letter n represents the number of molecules per unit volume. M represents mass of each molecule and K is the Boltzmann constant, and its value is 1.38 into 10 to the power minus 23 joules per Kelvin, and T is the absolute temperature of the gas, and C square is given by U square plus V square plus W square. Here U, V and W are the component of velocities along the three mutually perpendicular directions. So, Maxwell's velocity distribution equation doesn't give the velocity of individual gas molecule, but it simply gives the probability of number of gas molecules whose velocity lies between the two values c and c plus dc. Here, the term dn by n is equal to 4 pi a cube e to the power minus bc square into c square dc. This term represents the probability of number of gas molecules which are having the velocities between the two values c and c plus dc. This is the expression given by the Maxwell in order to explain the velocity distribution of gas molecules. Next, we will have the graphical representation of Maxwell's law of velocity distribution. In order to represent graphically, we need some mathematical calculations. Using Maxwell's law of velocity distribution equation, we have the probability of equation, that is the probability of number of gas molecules which are having the velocities between the two values c and c plus dc, that is given by dn by n is equal to 4 pi a cube e to the power of minus bc square into c square dc. So in this equation, we have to put bc square is equal to x square. Then x is equal to root of b into c. On differentiating this equation with respect to C, we get 2bc into dc is equal to 2x into dx. By cancelling the 2 on either side of this equation, we get dc is equal to x into dx by bc. Then, by substituting the value of dc and b value in the Maxwell's equation, that is in dn by n is equal to 4 pi a cube e to the power of b minus bc square into c square dc, then we get 4 pi b to the power 3 by 2, pi to the power minus 3 by 2 and e to the power minus x square c square x into dx by bc. Again, on simplification, we get 4 pi to the power of e to the power of minus x square into x square dx. Finally, we get dn by n is equal to x into dx. Here, y is equal to 4 pi to the power of x square e to the power minus x square. Then by plotting y against x, we get the curve, this curve. In this curve, we have the following results. They are the shaded region, means the blackened part in this graph represents the number of gas molecule, that is dn by n. That is the probability of number of gas molecules which are having the velocities between the two values c and c plus dc. Here the first part represents c and last part, here this part represents c plus dc part. So this part represents just the number of molecules which are having the velocities between the two values c and c plus dc. Then area under this curve represents the total number of gas molecules whose velocity ranging from 0 to certain maximum value or infinity. Then in this graph, the y coordinate represents the number of gas molecules corresponding to velocity for x value. Here the y coordinate represents the number of gas molecules whose velocity corresponding to x value, and the peak value represents the most probable velocity of the gas molecules. Most probable velocity means it is the velocity possessed by the maximum number of molecules. So, the maximum number of molecules corresponding to this peak or y is the maximum value. Therefore, the velocity corresponding to this value is nothing but most probable velocity. It is the velocity possessed by the maximum number of gas molecules. Then these are some of the results from the graph. If we study the Maxwell's velocity distribution equation as a function of temperature, that is, if we increase the temperature, the probability distribution curve become more flatten and flatten. That is, it become range is increases. On this curve, this graph represents the velocity distribution for nitrogen molecule at different temperatures. For smaller temperature or at lower temperature, the molecules will have less energy since kinetic energy is related to temperature. Therefore, for lower temperature, energy is less. Therefore, the speed of the molecules is also less and the velocity distribution is small. As the temperature of the gas molecules increases, the distribution of velocity distribution curve is flattened, which means At higher temperature, the molecules will have greater energy. Therefore, and the gas molecules will move faster at higher temperature. And the distribution curve is large. Again, if we consider or if you study the Maxwell's velocity distribution curve as a function of molecular mass, this graph represents the Maxwell's velocity distribution curve for different molecules. This is for oxygen, nitrogen, water vapor, helium and hydrogen. Here, the heavier molecules, usually we know that the heavier molecules will move slowly than the lighter molecules. Therefore, heavier molecules will have smaller velocity distribution curve, but the lighter molecules will have velocity distribution curve is flattened, or velocity distribution is more, means these molecules or lighter molecules will move with high speed. So these are some of the facts related to Maxwell's velocity distribution. Maxwell's law of velocity distribution. These are the books for reference. Thank you.